Hi everyone, welcome to tutorial 26 of our Introductory Python for Image Processing tutorial series. Now in today's tutorial I'm going to talk about plotting in Python using matplotlib library, specifically using Piplot module that's available under matplotlib library. Now when you perform image analysis, of course image processing is one of the steps as part of image analysis, but eventually to gain certain insights from your images, you may have to plot the data that you're extracting out of these processed images. And for that, Piplot can be a great, useful resource available in Python. Now, there are other libraries that I'll probably cover sometime in future as part of this tutorial series, but since Piplot is a bit important for the next upcoming tutorial videos, I plan on actually covering the basics as part of this tutorial. So let's jump into Spider. As usual, I have pre-written the code, but I'm going to, again, as usual, take snippets of this to explain this in a stepwise manner. So first of all, Piplot, again, you already should have it if you are working with Anaconda Spider. If not, go ahead and pip install matplotlib. Okay, and Piplot is available as part of this matplotlib. And again, if you get any error message when you try to pip install matplotlib or any other pip install, just put exclamation mark. So it runs this as a command line argument. Okay, so now once you have matplotlib, almost memorize this statement. Okay, from matplotlib, we are going to import Piplot as PLT. I include this line in every one of my, coding exercises. I mean, this is very standard, I would say. Not just me, almost everyone uses this. So from matplotlib library, we are going to import Piplot, okay, and we are going to import it as PLT, which is the shortcut for Piplot. So I can just type plt.plot and then plot whatever I would like to plot. So before we jump in there, let's actually copy a couple of lines just to show you how easy it is to do this. So first of all, how can you plot anything? So for plotting, you need to have x-axis and y-axis. You can generate x and y using NumPy, for example. But in this case, let's actually generate a few values of x and few values of y just by using simple Python lists. Okay, so x and y are lists. So if I just select these two and run these lines, there should be a list you can see up here of size 5. Now I have my x and y, so all I need to do is plt.plot. So again, let me type this, plt dot, okay? You can do a whole bunch of things as part of your Piplot, okay? So what am I doing in Piplot? I'm going to plot. If you watched my previous tutorial about loading images, we used plt.imshow, imshow. So let me plt.imshow. When you put dot imshow right there, okay? So right now we are going to use plt.plot because we are just doing two-dimensional plot. And what do we want to plot? X and y. So it takes the first one always as x, second one always as y. So if we go ahead and plot it, here you just see a plot right there. So this is how easy it is to plot using Piplot. Now there is a lot more you can actually do with this, right? I mean, you can also use, for example, NumPy arrays. So your image is nothing but a NumPy array. So let me copy these lines so I can show you how to do NumPy array plotting. So all I'm doing right now is taking my x and converting that into a NumPy array. Again, so it becomes an array instead of a list. Okay, so if you again look on the top right there, this NumPy array, each element is integer 32-bit and then the size is 5. Okay, so now plot A and B just like before. You should see exactly the same thing. Okay, so what else can you plot? I mean, I showed you how to plot images in the last tutorial, but just for the sake of completeness, let's go ahead and do that. So I'm going to copy a few lines and create some room down here. So I'm going to import CV2, which is OpenCV, and then read an image called sandstone.tiff in grayscale, and I'm going to assign that to a variable called gray image. And let me run these 2 lines of code and show you how the output looks like. So the gray image is a NumPy array of size 481 by 674, and all the values are unsigned integers 8. Okay, so this is our image. This is our 2-dimensional NumPy array, which is nothing but our image. So if we use plt.imshow, I'm going to map. It's still plotting. It's still plotting, except now I'm plotting the intensity or pixel value at every pixel here. So now you can actually see an image, which is nothing but, again, the plotting of intensities in 2 dimensions. You can also plot histogram of this image. What is a histogram? I just want to see how many pixels of these bright pixels do I have? How many of these dark pixels do I have? So basically plotting a histogram plot. And how do you do that? We already have numbers, right? I mean, if I open my gray image right there, each value here is a pixel value, except this is in a 2-dimensional grid. I just need 1-dimensional. That's it. For histogram, I just want to look at the frequency. So to do that, the way I do that is take your 2-dimensional grid and put dot flat, which means it kind of flattens your 2-dimensional grid into 1 dimension. And then I can just define, okay, plot into bins of 100. Use 100 bins within this range, 0 to 150. If you have 0 to 255, because this is an 8-bit image, go ahead and use 0 to 255. So that's all this is. And then plt.hist is actually plotting a histogram. Here we plotted a plot. If you don't say anything and just do .plot, that's just a line plot. If you do plt.histogram, that's a histogram plot. plt.bar, that's a bar graph. Okay, so let's go ahead and plot plt.histogram. And on the right-hand side, you should see the histogram of this image that we just looked at. Again, you can change the range to, okay, I don't want to see up to 255. I only want up to 150. Go ahead and run this line one more time. There you go. You only see up to 150. Okay. So, so far we looked at how you can actually plot your using matplotlib, and let's actually continue by exploring a few other things. So let me copy this next set of lines from here and paste it here. So again, I'm importing my pyplot from matplotlib. Now, again, I'm defining my NumPy arrays over there. Okay, this is no different than what we have done until now. And plt.plotab is what we have done already before, and it's showing us this blue line. Now, what else can we do? So let's actually, instead of plotting it as a line, let's actually plot this as blue O's or blue dots. Sorry for changing it. Blue dots. BO stands for that. So if I go ahead and run this, you should see that, okay, now instead of a line, these are blue dots. You can also do like I mentioned here, try, for example, red dash dash. Okay, what does that actually mean? Hyphen hyphen. So that means it's just a dashed line, right? So you can also try the green triangles if you want. Okay, so try G stands for green, and you can find online documentation about what other types of plot can you do. I just want to make sure you get started with this. Okay, now you can actually define the axis range. As you can see, it's going from 0 to 5 and in X, and 0 to 25 in Y. So if you actually define plt.axis, then you can actually define the axis right there, 0 to 5 or 0 to 25. Okay, so you can select these two combined, and then let's run this, and now you can see 0 to 6 in X and 0 to 50 in Y. Now anytime you do PLT and you follow up with an action, these are all combined. Yeah, plt.plot and plt.axis. In fact, if I do all of these 3 lines, it may look a bit awkward over there. You see how I have, well, in this case it makes sense. I'll show you when it gets awkward later on. So what's happening here is it's first defining the plot, which is a line plot, and then it's defining a plot which is a green triangular data points, and then it's defining the axis, and it's sharing this axis, this graph, for all of these actions under PLT. Okay, please go ahead and practice this until it makes sense to you, and I'll show you a few other examples so it makes a bit more sense. Okay, so let's actually now take a different type of data. So let's go back And hopefully some of you from biology can relate to this. Okay, you have a cell discoverer with 92 wells or so, so on. In this example, I'm showing you 5 different wells, and in well number 1 we have 80 cells, well number 2 62 cells that we imaged, and 88, 110, and 90. So what type of plots can we actually do? So let's go ahead and do plt.bar. As you can imagine, that would be a bar plot. Yeah, so that's a bar plot. Plt.scatter would be a scatter plot. And plt.plot, you know what that is. This is just a line plot. And again, just to show how awkward things can look, when you select all of these and run, all those are displayed in the same plot, completely overlaid, meaning all the actions under plt dot are sharing the same axis. Okay, this is how PyPlot actually is designed to work. Now, if you want to separate them into different plots, we can do that, and I'm going to show that in a minute. Okay, so moving on, defining the line properties. Okay, what else can you do when it comes to line plots, for example? So let me do this again. So we have our A and B data points here, and now I'm defining a line width of 5.0. If you don't put anything, right? If you don't put anything, which is what we did, it uses whatever the default is, and it's showing this in whatever the line thickness is, I believe, which is 1 pixel. Now I'm defining line width as 5, and if I just run this, you should see that my line width is 5 pixels now. Okay, now you can also, instead of defining individual properties, you can actually define multiple properties at once. So here, by using setp, setp, okay, here I'm applying, first of all, I'm defining a figure, okay, instead of plotting. This is new now. Instead of plotting plt.plot, I'm saying, okay, this is a placeholder. I'm calling it fig, F-I-G. The placeholder is for a plot, plt.plot a comma b. Okay, and to that actually add these properties to my figure, change the color to red and line width to 4, and then show the plot. So if I run all of these together, now we should see a red line right there where it's applying all of this. Again, I'll show a couple more examples. PyPlot can do a lot. I just want to give you a few basics with this video, so you know exactly what the potential is. Now actually let's add annotations, and what I'm going to show you right now is probably a very comprehensive. Now we'll actually see a plot that's very presentable and nice. So going back to the same example, okay, wells, well number 1, 2, 3, 4, 5, and how many cells do I have? 80, 62 or something. And the first line is again a placeholder, plt.figure. My figure size is 8 by 8. Now I started to define what my placeholder size is, so I can plot my my values. And I'm going to plot a bar plot, okay, and x being wells and y being the cells. And then I'm going to add to that plot, see how I'm doing plt dot. So to that plot, I'm going to add x label, and the label will be well number, and with a font size of 18 and in color red. If I don't define that, it's going to use default. Same with my y label, except I haven't defined the font size and color. And you can also define title by plt.title, okay? And the axis, again, we looked at this earlier, right? So what is the minimum x, minimum y, maximum x, minimum y, maximum y, okay? And then plt.grid true. That means place a grid in my plot. And then just show. plt.show means show this. So if I run this, now you should see a bar plot with my x label as well in red at font size 18. My y is number of dead cells in whatever the default size and font. And we have the title up here. And this is a very nice plot, as you can see, with the grids and everything. Okay, so this is a very standard way of doing your plotting. And let me show a couple more log scale. Again, like I said, this is a very big topic all by itself. It can be like 10, 15 different series of videos, but we will be using various ways of plotting in our future videos, so you will definitely have a second look at this. Okay, so I'm defining list 1, 2, 3, 4, 5 and list of y with certain numbers over here. Obviously, the numbers these are some random numbers, but they're good for logarithmic plotting. Okay, again, I'm defining a plot with a figure size of 12 by 6. Now I would like to put two plots side by side. One, a linear plot, the other logarithmic, so we can see how the difference is. So to do that, we are going to add something called subplot. If you don't do that, you know what's going to happen. If you don't do subplots, and if you just do PLT, all the plots are going to be in the same figure, in the same axis. To create your new axis or new plots side by side, we have to use subplot. Okay, so plt.subplot, I'm saying I want one row but two columns. So I'm going to put one row, two images side by side. Okay, so one row, sorry for changing that, one row, two columns, and this image is going to be the first one. Okay, which is my linear plot. And later on, I'm going to do exactly the same, plt.subplot, one row, two columns, but this image is going to be the second in position. That's what this means. 1, 2, 2 basically means. I'll also show you how to define this an alternate way in a minute. Okay, so what are we going to plot? X and Y, and Y scale, linear. In fact, if you don't give it, it's by default linear. And I'm going to put a title called linear, so we know that, okay, this is linear. And grid, let's go ahead and add the grid. And as you can imagine, for log, the only difference is Y scale is log. So if I run this, you should see two plots side by side with the grids on them, with the titles as linear and log. And here, this is linear scale, as you can see. Look at the numbers, and here, this is the log scale. Okay, which means our data points are going to be a straight line almost, right? I mean, these are increasing in a logarithmic way. Okay, so finally, maybe a couple more. Just because I showed you how to put these things, how to do subplots, this becomes very important. When we do our image processing and you would like to put before and after pictures, you need to know how to put these, arrange these plots or images. So let's learn a bit more about it. So now I'm going back to the earlier example where we took this well 1, 2, 3, 4 and then certain values for number of cells and then plotting bar, scatter and plot, and you know what happened when we ran all these together. Everything got combined into one plot. Now I want to plot them into separate plots. So to do that, I'm going to first plot horizontally. So let's actually put a figure size of 16 by 6. Okay, again, you can play with what works. And let's plot one row and three columns, okay? Which means three images side by side. And the way you define that is one row, three columns, and the first image is going to be bar. The second image is one row, three columns, the second image, okay? So the last letter is the position, indicating the position. And here, the third one, okay? And the subtitles, SUP title, is basically the title for all of these plots. For individual plots, you can actually put title, okay? I can actually go down here and actually put subplot, and then I can actually add plt.title, and I can add title for this one, saying only bar. So let's go ahead and plot this. So you can see all these three plots side by side. Let me create a bit more room so you can see it. Okay, so bar plot, scatter plot, and the other one. Now, just for the sake of completeness, I'm going to plot these vertically. Actually, let's do a grid, which makes it a bit easy. Vertically, it's basically instead of 1, 3, 1, you just do 3, 1, 1. Okay, so let's actually plot this as a grid. And how do we do this as a grid? I'm going to now put a figure size of 12 by 12. Okay, pixels. I think, no, that's not pixels. That I forgot what the units of these are, but 12 by 12. And the first plot, 2, 2, 1, which means I want to arrange my plots in a grid of 2 by 2. And this is the first one. 2 by 2, this is the second one. 2 by 2, this is the third one, and pretty much the same for everything else. Now we should see our plots in a nice 2 by 2 grid. Okay. Okay, finally, let's end this video by looking at the same thing, but in a different way, because you will see when you try to steal code from GitHub or wherever, you need to know exactly how to read, because different people have their own styles of plotting. And I mix my style of plotting, but let's go ahead and look at a different style here. Again, the same data here. I'm not doing anything different. So our wells and cells, except here you are initializing a figure just like we did earlier by saying plt.figure, and figure size is 16 by 6. And then I'm creating a variable called ax1. Think of it as axis 1. Okay. And I'm going to add a subplot at position 131. This is a slightly different way of doing the same thing that I showed you earlier. It's up to you, whatever you think works for you. Okay. Again, 131 means 1 by 3 in terms of rows and columns, and this is the first one. And then you can do ax1.set, and in set you can actually set a whole bunch of things: title, the x label, the y label, and so on. Same thing for the second axis. Sorry, this should have been ax2.set. Okay. This would be horizontal bar and so on. And ax3, another subplot. Okay, so you can add different subplots and then go ahead and plot it. So let's go ahead and, by the way, at the end, I'm adding plt.savefig. This is a way of saving your figures as an image. Okay, so let's save it as myplot.jpg. So when I run the code, you should see that, okay, this is vertical bar title, and that's exactly what we gave it here. And for axis 2, or the plot 2, we gave the title as horizontal bar. And for the third one, we didn't give any title or any formatting. So it just did a default plot because that's our plot right there. Okay. And by the way, to define the horizontal bar, you just do bar h. Bar h is your horizontal bar plot. So where did it save? If I go to my images, there should be a file called myplot. MyPlot right there. And here you go. A nice way of exporting your plots. Okay, so I hope you learned, you found this tutorial to be useful, and the reason for covering this at this stage is to make sure we know how to do certain plotting when we go on to image processing parts. So let's actually cover a different topic in the next tutorial, and thank you very much for your attention.